gonna let me. Is it recording? Yep, it's recording. Okay. Well, I guess I could just go with this. Let's see. Do y'all know how to take that derivative?
Can we bring the two-thirds down?
Yep. We'll bring 2/3 down. Oops, I forgot my little prime. So bring 2/3 down, and then you got x cubed minus 8, and then what happens to your power?
It goes down.
Okay, so subtract 3 over 3, and what do you get? Negative 1/3. Alright, and don't forget to put your do outside. So the derivative of the inside is 3x squared. Okay, now you got to worry about, okay, who goes where? Which side? Okay, the 2 is up top, and this part is up top, right? I guess we could have gone ahead and multiplied together. The 3's in the bottom, and since this has a negative power, he's in the bottom. They just went ahead and made it like a cube root. Now, do y'all see what you can reduce? The 3's. 3's cancel. And if you went ahead and multiply that out and had 6, it'd still reduce. So you've got 2x squared up top, and then you just got the cube root down the bottom. Yeah.
I thought it was a 3.
It is, but we've got the 2 from here. Is what's there. See, the 3's canceled out. You had 3 in the bottom, you had 3 in the top. So since they canceled, you just left the 2.
So when that 3 cancels out, the x behind it cancels out too.
No. You still need the x squared. See, that's the reason I put in here. I got the 2 from out front, I got the x squared there. You could think of that like it's 6x squared.
I thought that was a 3 right there. The 3x to the third.
Oh, well, bad.
It was kind of the same thing.
Okay. Alright, so I gotta have 2x squared at top. This is the only one that's got that. Okay. So, here we go. Now, this was a happy problem. Please tell me you got this. Find the location of this value. So, you want the minimum. And what would you say? Yes. There's your bottom right there, and it happens when x is 3. It didn't really ask you what the y value is at all. It just says, you know, where's the minimum when x is 3. That's when it hits bottom. So, everybody should get that one. But now you can see you transitioned into the max and min part of the test. Okay, so find the location of the indicated absolute extrema within the specified domain.
That's how that works.
Okay, but we want the minimum out of that. So, I mean, if that's blowing your mind, just look at this. You want the min, and it's giving you endpoints. So how do you find critical numbers? Okay, well, we need to take our first derivative, right?
God.
And we got to set it equal to 0. So we can take out 3x, and that leaves 1x minus 2. Shame on me.
X minus 2?
Uh-huh. So I got 2 critical numbers. But I also have 2 endpoints. If I'm going to find the minimum, the easiest thing to do, because I worked through this thing yesterday, the easiest thing is just try to find your y values. And the good thing is, one of these things doubles up. You got 0 in both of them. So you really only have to check 3 numbers. Which 0? This one? You see I got the x up front? So I'm going to do f of 0, and I'm going to do f of 2,
F is 0 is 0.
and then I'm going to do f of 4. Yes, ma'am, you're right. If you put 0 in the original, you get 0. So, done. If you put 2 in the original, that's 2 to the third minus 3 times 2 squared. So I got 8 minus 3 times 4. 8 minus 12 is negative 4. Right, now stick 4 in there. 4 cubed minus 3 times 4 squared. 64 minus 3 times 16. What is that, 48? I think that's 16. Is that right? So who's the smallest?
Zero.
Okay, wait a minute.
Oh, negative 4.
Negative 4 is smallest.
Oh.
So since that's the smallest y value, what's our answer going to be? Because that was the x value that gave it to us. So I want to make sure that that connects with your head. You're not looking for negative 4 in your list. You're looking for 2 in your list because that's what you plugged in to get the negative 4.
Gotcha.
Okay. I'm actually getting hot. Are you hot? I'm getting warm. I think it's doing a good job. All right, so same question, different problem. So attack it same way. And then first derivative. And then set that thing equal to 0. That one ends up being pretty easy. You've got one critical number, and then you have both endpoints. You just need to see who's tallest because you're wanting a maximum. Oops, I meant to underline that, not strike it out. So we've got to go in, we're going to plug in a 0. We're going to plug in a -1. And we're going to plug in a 2. We're going to plug it into the original to see what the height is. Okay, so
0.
that's, no, wait a minute. If I put 0 in there, that's going to be -4. Okay, so, oh, you're saying my answer. Okay, so if I put -1 in, -1 squared minus 4 is 1 minus 4, which is -3. If I put 2 in, 2 squared minus 4 is 4 minus 4, which is 0. Which one's the biggest?
2.
Okay,
Biggest
so
is
the
0.
biggest y value is 0. The x value that made it is 2, and that's what he's saying. It just kind of gets, there's a lot of information. Okay, so find the location of all absolute extrema if they exist. So all they're asking you to do is, do your critical numbers and do exactly what we just did. It's a different, let's do it again. Alright, so prime of x is -12x cubed plus, what is that, 48x squared, 36x. Alright, when you set that thing equal to 0, what are you going to need to do to that thing? And I would take out a -12 if I was you. And yeah, x. And when you take out the negative, just know that all your signs are going to flip-flop. So you're going to have x squared, and it's going to be minus 4x, and it's going to be plus 3. Alright, now that should go again. What do we get?
3 and 1.
3 and 1. What's our signs look like?
Both negative.
There you go. So this first thing gives me a 0. This one gives me a 3. This one gives me a 1. Okay. Now I will tell you this. On this problem, it was a little tricky. If you'll just think about the way this thing behaves, you've got these critical numbers. Look at what it says your end behavior is supposed to be. If you got x to the 4th, are your ends doing the same thing or opposite things? Same. Since it's negative, are they both up or are they both down? Both down. So you know that one end's down and it's going to go boopity boop 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 and then come back down. Okay, so are you going to have an absolute minimum?
No.
No, you're not. So this should make perfect sense right here. We're probably going to have, one of these is probably going to be taller than the other one. So, I mean, all honesty, I would purposely check the smallest one and the biggest one and not worry about the middle one because that's the dip in the middle.
The smallest would be.
Smallest one would be 0, right? So if I take 0 and I put him into it's 7. Okay. So then you've got, let's try the big guy, which was 3, and put him in. This is going to get stupid. Okay, so 3 to the 4th plus 16 3 to the third minus 18. 3 squared plus 7. Yes, just let your fingers do the walking.
I got 34.
34? Okay. Is that okay? So that means that 3 is your absolute maximum, and there's not an absolute minimum.
B.
Yeah, B. That's it. All right, let's see here. Oh, this is, remember whenever we did the optimization problems the other day? Were y'all all here? Ron, you weren't. Were you here when we did the optimization problems? Yes. So this, if you want me to work it the optimization way, I can. Or you can, guys, you can just sit there and play with your numbers. Find two numbers whose sum is 200 and their product is as big as possible. So make sure they all add up to 200. That does, that does, that does, and that one does. So they all add to 200. Now, who's going to have the biggest product? If you did this, isn't that going to be...
Product, that's times?
Yeah, product is times. That's 199. And I don't know what that is, but what is that going to be?
That's 10,000.
10,000. You think anybody's going to be bigger?
I don't know about 99.
Okay, we'll try 99 101. What is it?
9,999.
9,999. So, winner, chicken dinner. I mean, I can show you, if you want me to show you how it works,
But
I'll be glad to show you how it works.
D.
Or you can do that. Okay.
I like it.
Okay, yes, D. On the thing that I actually hand wrote, I've got all of that. This is the other one that is optimization. Okay, but wait a minute. Again, common sense can help you figure this out. I would draw the picture just so that you can kind of get a sense of what's going on. Rectangular field, 4 sides of fencing. Fence costs $6 on one side, and it cost $3 for the other sides. So I would do that just so that I knew what was going to go on. So it says find the dimensions of the field. Now it does say that the area has to be 830. Okay. So can you use that to help at all? Yes, you can.
Yeah.
Yes, you can. Because look right here. What is, type this in, what is 57.6 times 14.4?
829.4.
829.4, so that's pretty darn close. So what is 20.4 times 40.7?
Times 20. Or 22, 21.
You got 20.4 times 40.7.
28 something.
What'd you get?
830.28.
Well, these are really close, huh? And then we got 40.7 times 20.4.
830.
It's the same thing, isn't it? And then this is this same numbers. Okay. Well, that doesn't really help you a whole lot, does it? Okay. All right. Well, I can show you how to actually work it. All right. So the way you got to do it is x, y. So I'm going to say this is x and this is y. X, y has got to equal 830. They told you the area straight up. But what are you trying to minimize? Because it says cheap. Oh, cheap. We'll have to finish this one in the next video. I'll just say that. We'll go to lunch and we'll come back and we'll finish this. So